This is 9.6b of algebra. So we've looked at a lot of different methods to solve quadratics. So let's figure out exactly which ones we know and why we would use it. One that we've done, graphing, we're not really going to focus on. There are certain cases where you can graph it, but you don't really want to graph it unless you know that you're going to hit a point exactly. And I think it's the most work because you got to have graph paper, you got to graph it right. So we're just going to look at the other methods, okay? So, factoring, okay, when we put it in parentheses, you should use factoring when a is equal to 1, so when that first coefficient is 1, so it just starts out with an x squared, okay, and you can factor it, which might seem kind of obvious, but if it multiplies to the end number and adds to the middle number, then do it. If you can't factor it, completing the square comes in. Okay, we use completing the square when a is equal to 1 and you can't factor. A special case is using square roots. Okay, you're using square root when you have the x squared term, but no x. Okay, so if you look at this problem up here, a, we have an x squared, but there isn't any x in there, right? If you look at this one, there's an x squared here, there's an x here, so I wouldn't use square root. There's an x squared here, and there's no x's, so then you'll use the square root. And lastly is our quadratic formula. Basically, you're using this anytime. Okay, this works for all of them. Here's the deal, though. I wouldn't make the quadratic formula your go-to, okay, because it's a pretty long process, and there might be a shorter method. But it does work for any of them. We especially use it when a is not equal to 1. But otherwise, if there's decimals involved, that sort of thing, you could use a quadratic formula. It might be nice. So let's look at our problems here and decide which ones we should use. So let's start by looking at A. Okay, first thing I would check, well, first check to see, can you do the square root? No, because I've got an x squared and I've got an x term, so that won't work. Can I factor this? Are there two numbers that will multiply to be 12 that add to be negative 8? If I did negative 2 times negative 6, that'll give me a positive 12, and that'll add to negative 8. So for A, we should use factoring. You don't even have to solve it. You just got to say which method should you use. So for B, I've got an x squared term. I don't have an x term. So for B, I should use square root. And for C, the first thing that you should notice is that there's a 5 out front. So then we'll use the quadratic formula. Okay, we're going to continue with a piece of the quadratic formula that's called the discriminant. Okay, you can use their definition. I would just say the discriminant is the stuff under the square root. It's this, b squared minus 4ac. The discriminant is important because it tells us how many solutions we have, okay? So if the discriminant, b squared minus 4ac, is greater than 0, which means it's positive, then that means that there are two solutions. Okay, you can see it on the graph there for an example. There'd be two real number solutions. If the discriminant is equal to 0, then that means that there's one solution. It just touches. Okay, and if the discriminant is smaller than 0, meaning it's negative, then there are no solutions. It doesn't cross the x-axis at all, and we have no solutions. Let me give you a brief little example up here of why this works. Let's say I get down to 3 plus or minus the square root of 16 over 2, right? So my discriminant, the stuff in the square, under the square root, is positive, so this is our first case. This would be 3 plus or minus 4 over 2, and I'd make my two equations, right? 3 plus 4 over 2, 3 minus 4 over 2. And that's going to give me two different answers, right? 7 over 2, and this would give me negative 1 over 2. If the stuff under the square root is 0, so let's say we've got 3 plus or minus the square root of 0 over 2. That's 3 plus or minus, well, what's the square root of 0? That's just 0 over 2. If I try to make my two equations here, 3 plus 0 over 2, 3 minus 0 over 2. 3 plus 0 is just 3, so this is 3 over 2. 3 minus 0, that's just 3, so this is 3 over 2. They're the same thing, right? I only got one answer, because it doesn't matter if you add or subtract 0, it's not going to change it. And lastly, if this stuff is negative, so 3 plus or minus the square root of negative 9, let's say. I can't take the square root of a negative number, right? That's not possible, so there are no answers to that. So let's try figuring that out. We're looking at our got it problem down here. It says, how many real number solutions does 6x squared minus 5x equal to 7 have? So remember, we're going to treat it as if we're doing the quadratic formula, so it needs to be equal to 0. So I'm going to subtract 7 from both sides. 6x squared minus 5x minus 7 equals 0. Now I can figure out what my A, my B, and my C are. Okay, if you need to, match it up, but otherwise, your first number is A, so A is 6. My second number is B, so B is negative 5, and C is negative 7. Now I don't have to plug it into the whole quadratic formula. I'm going to plug it into the discriminant. B squared minus 4AC. So B is negative 5, so negative 5 squared minus 4 times 6 times negative 7. So negative 5 squared, that's 25, minus, and then I need to do 4 times 6 times negative 7, which gives me a negative 168. So this turns into 25 plus 168, which gives me 193. The actual number you get doesn't matter. You just need to know, is it positive, is it 0, or is it negative? It's positive, so this means that I have two solutions. And there's your homework.